So thank you again to everybody for joining the Danube Water Forum. We had a really excellent first session setting the scene and getting that overview context of what the current situation is and the ongoing challenges. So now we're going to flip the script a bit and really dig into some of these opportunities and solutions that we can be looking at to address some of these challenges. So if you weren't here yesterday, my name is Katja Havens, and I'm a program analyst with the Danube Water Program, joined in 2019. This is my first in-person event with the Danube Water Program and first Danube Water Forum, so I'm very excited to be here. I'll be co-moderating with my colleague, Mr. Stepan Gabric, who is a senior water supply and sanitation expert. He's joining online. He unfortunately has an ankle injury, so we figured between the injured guy and the pregnant lady, we could probably co-moderate the session. So over to you, Stipe.
Thank you, Katja. This is really interesting introduction to the session. Appreciate it. When I was following the previous session, I really have to admit that I couldn't think about a better introduction into our session than the previous session has actually done. And it has made very clear that situation in which we are now, basically emphasized by the significant hike of energy costs, including the electricity, is with us to stay. This is not temporary deviation that will disappear. This is going to be the standard operating environment in which our sector will operate for the at least midterm period. And to be completely honest, we are, including myself, probably still in a state of some sort of self-denial. I mean, saying, okay, this is going to be for a few months, by winter, we'll go back to the normal. No, it ain't going to be the case. This is our present, and this is our future status in which we are going to operate. Now, this might sound very worrying and concerning, but on the other side, one need to realize that the crisis and necessity is the mother of all innovations. Usually in the time of plenty, in the time when everything is working more or less normally, we do not really, push very hard to, change things. Do not push to innovate simply because, there is no need, there is no pressure on us. Pressure and necessity, as we are seeing now, is basically the main driver of the technological process through the human history. So I have no doubt that this basically crisis will result in significantly different water supply and sanitation sector from technological point of view in the midterm period at least. Now, with this idea in mind, we thought that we should prepare a session that will be focusing on technology and innovation and technology, and to see what kind of responses we can come to this challenge that everybody is now facing, which, as I just said, and previous session clearly outlined, is not temporary. This is going to be our modus operandi for a time to come. So we decided basically to try to present 2 points. On one side, we tried to present different water utilities. We selected one wastewater utility and one water supply utility, and tried to present what kind of approaches they are taken, mostly to create on-site generation of electrical energy. And on the other side, also tried to invite some of the leading industrial technology companies in Europe to present what is the cutting edge of their technology that they can offer to the market. So then combining those 2 aspects, on one side, companies that are already utilized a certain level of the on-site generation and energy production, and cutting edge technology that is present on the market or just coming to the market, we are clearly will be hopefully at the end of this session to have more clear idea what exactly is already being done and what actually could be done in the future. Let me just finish this short introduction with a conclusion and repeat my own words by saying we need to understand that this is going to be focus of our activities in water supplies and sanitation sector in the coming period more than anything else. So please stay focused. This is hopefully going to be very interesting, and I believe we will learn something, including myself. So thank you, Katja, and over to you.
Thanks, Stipe. So I'd like to open the floor or screen for our first virtual presentation to Mr. Jelaz Ranglov, who will be presenting on renewable energy production and as a case study from Sofia. So, Jelaz?
So, hello, everybody. It's okay with the screen sharing?
Looks good, thanks.
Let me first introduce myself. My name is Jelaz Ranglov, and I'm working in the field of wastewater collecting and treatment in Sofijska Voda, which is a part of Veolia. I'm working now from Sofijska Voda more than 10 years in this field. I have a lot of slides, but don't worry. I will go briefly through the most of them, and I will stay on the important ones. So first, in brief introduction of Veolia. Veolia is a leading company in the utility sectors. It's working in the fields of water, waste, and energy management. We have more than 120,000 employees worldwide after the merge with Suez. In the Central and Eastern Europe zone, which Bulgaria also is in, we have a business in 14 countries. And in Bulgaria, we have technical services in the smaller city and a heating company in Varna, which is on the Black Sea, and the municipal water and wastewater in Sofia, which is the main and the biggest business of all in Bulgaria. Let me introduce the Kubratu wastewater treatment plant. This is how the plant looks like. The plant was designed during the 90s, the 70s, 1970s, and until recently it was the biggest on the Balkan Peninsula. Now the plant of Bucharest is bigger than Sofia, but it's also part of the Veolia water. The treatment capacity of the plant is about 480,000 cubics per day. And the plant is located in the lowest part of Sofia Valley. So this is very important because all the sewage system of Sofia is by gravity. And the water is flowing through the plant also by gravity. We don't have pumping station. The plant was commissioned in the 1984. And these are the flow parameters. We can treat maximum flow of 680,000 cubics per day. And the loads for the most important pollutions. We had a lot of reconstructions over the years on the plants from 1996 to 1991 and 1999. We have a project for reconstruction of the sludge treatment facilities. 2002 till 2004, it was a reconstruction of the water treatment line. In 2006 is a very important year. We finishing the reconstruction of the sludge treatment facilities, and we starting the operation of our digesters. In 2009, of course, this is also important, we installed the CHP plant. 2010 to 2011, we reconstruct the biological line again, and we implement the third stage of treatment, so we treat also nitrogen and phosphorus. In 2019, 2020, we built a fifth digester. It was the biggest project of Sofisco done for this year. We have, of course, a SCADA system, and this is how the SCADA of Cobra-Tuets look like. A brief introduction of all the equipment of in the plant. We have 10 channels and 10 current and fine screens. Then the water is going to sand and grease removal. We have 3 lines for sand removal. The water after the sand removal is going to primary settling tanks, 4 pieces in diameter of 54 meters. And after the primary settling tanks, the water is going through the heart of the plant, the biological treatment. We have 6 lines working with activated sludge. We have a lot of measurements and automatization in the biological step. After the biological treatment, the water is flowing through 10 pieces of secondary settling tanks. They are the same like the primary settling tanks, but only the number is different. We have 3 pumping stations for the secondary settling tanks. This was the water treatment line, and we divide the tanks into the water treatment tank and the sludge treatment line. The sludge from the primary settling tanks is going directly to the digesters, and the activated sludge is going to first 2 pieces of gravity thickeners, then 4 mechanical thickeners, and then the mixed with primary sludge and activated sludge is going to 5 digesters. And the end of the sludge treatment process is the dewatering of the sludge. We have 5 belt presses. And of course, our CHP plant. Before the plant, we had a lot of biogas that we cannot use in the boilers, so we burn it on the flares. And after that, this is our 4 generators. From 2011, we are very focused in the energy efficiency. We did a lot of CapEx projects for increasing our energy producement and for decreasing the energy consumption of the plant. In 2016, we installed a new gas holder. The main reason for installing of the gas holder was to can overall our existing bigger gas holder. The useful of the new one is about 1,000 cubics, and pressure inside is about 35 millibars, like the system. In 2017, we installed additional heat recovery system for the CHP's exhaust gases. The main goal was, of course, additional heat production, and we cooling the gases of the CHPs from 250 degrees Celsius to 90 degrees Celsius. And we won additional about 600 kilowatt hour of heat. In 2017, again, we install new blowers for our biological treatment. The blowers in one plant is usually the biggest consumer of electricity. So with the new technology, we reduce our energy consumption with 11%. The advantages of the new blowers, they're with magnetic bearings. They have no vibrations. They have very low maintenance and operational costs. For 5 years, we change only the filters for the air. Of course, because of the magnetic bearings, they are very high energy efficiency, and they have no need of additional cooling. In 2020, we put in operation our new digesters. The volume of the digester is 7,000 cubic. It's the same like the old ones, the old 4 ones. Our old digesters are with gas mixing, but the new one is with mechanical mixing. The operation is the same like the other ones, mesophilic operation, 35 to 38 degrees. And the biogas production is about 6,000 to 8,000 cubic per day. Our STAR system for optimizing the process in Kubratu was started in 2013. The STAR system is additional software to our SCADA system. And the STAR system is monitoring the parameters of the plant and is optimizing the phosphorus and denitrification, nitrification process. In 2019, we implement additional model for nitrification, denitrification phase control. And the total nitrogen effluent was reduced by 5%. In 2021, we will upgrade the STAR system to hub-grade performance plant. The hub-grade performance plant will operate from the cloud, and we will implement more modules than we don't have now. Return activated search, solid retention time, and flow distribution to the biological lines. This graph showed the electricity production from 2010. We are producing energy from end of 2009, so the real start was 2010. We can show, we can see the trend that mostly every year we have increase in the electricity production. This is because of a lot of technological optimizations and, of course, implementing of more electricity effective equipment. This graph showed the electricity consumption of the plant and the coefficient for energy self-sufficiency. Practically for 2014, we are energy self-sufficient in the plant, and the coefficient in the last years is between 110 and 120%. So we are covering our needs of electricity, and we are selling electricity to the network. But our dream now is to reach an energy independent water supply system. And like we saw, it's no longer a dream to have wastewater plants that are self-sufficient. It's also possible to have energy positive water cycle, and we can make this well known, and it can be like the norm within the Veolia group that every water cycle will be sooner or later energy self-sufficient. So thank you for your attention.
Thank you very much, Elias. So now we're going to be traveling from Sofia to Vienna. So I'd like to invite Mr. Wolfgang Gruber to the stage to present on the case study of Vienna water. Thanks.
Thank you, Katja, for your introduction. Dear colleagues, energy, the topic that was catapulted on the agenda of almost every utility, every enterprise, municipality, province, country. So next I will share with you some aspects on how Vienna Water is treating this issue. First, I will start with a short introduction of our system. You see the city of Vienna, that's the red spot, is supplied mainly by two transport lines, conducting the spring water by gravity into the city. You see the first so-called spring water main that was put into service in 1873 with a length of 150 kilometers. And the second spring water main with a length of 180 kilometers that has a length of 180 kilometers and was put into service in 1910. Some characteristic values, I will not focus everything of that. So we have 1.9 million inhabitants in Vienna. The water demand is about 390,000 cubic meters per day, ranging from 300 to 520. That means an annual consumption of 143 million cubic meters. There are 99 catchments, that's springs and wells. Spring water is covering about 95% of the demand, and well water about 5%. There are 31 water reservoirs with a total storage capacity of 1.6 million cubic meters, which corresponds to about 4 times the average daily consumption. There are 26 pumping stations, about 3,000 kilometers of pipe network. The losses we could reduce to 7%. There are 103,000 house connections. We are 570 employees, but that's just drinking water. Working in 3 provinces. We have seen before where the water comes from. It's Lower Austria and Styria. The tariff is 2.02 euro per cubic meter for the drinking water and 2.22 euro for the sewage water. In total, we have 16 drinking water power plants. 14 are operated by ourselves and 2 are operated by the municipal electricity company. The same with photovoltaic power plants. 1 small is operated by ourselves and 1 by the municipal company, by the electricity company. Just some aspects, a gallery within one of the mains and an aqueduct, 150 years old now. Here you see a situation of the reservoirs. They're all situated mainly on the hilly side, on the hilly west side of Vienna. And on the flat part, there's almost no reservoir. Here is the photo of one of the oldest reservoirs where the first spring water main is discharged into. The red line, you see the development of population of Vienna. During the monarchy, there was a strong race until the First World War. Then there was a decline until the fall of the Iron Curtain. And since then, this was 1990 about, and then we have a strong increase again up to now. On the blue line, you see the demand, always increasing up to 1970. What happened here? There was a program of detecting leakage within the households. So Vienna Water also looked inside the houses of running taps, of leaking toilet flushes and so on. And the result was that in total, we could reduce the demand about 20%. Here you see also the efforts of leak detection within the pipe network. So the last years, there's a long increase again, and this is the forecast for the next year. So still we expect a strong increase of population and a moderate increase of water demand. So maybe you've heard the words of a certain Mrs. G. Thunberg. She said, "Our house is on fire." And with this, she's absolutely right. Sorry. You see here the graph of the mean summer temperatures in the northern part of Austria, where Vienna is part of. And you see here this amazing increase of temperature. We're holding now with a plus of 3 degrees in comparison to the period 1960 to 1990. And of course, this line goes up. So we face a really change of boundary conditions. How's the situation in Vienna? The consumption side, we need a total of 24 gigawatt hours per year. This is being composed of about 20 gigawatt hours electricity, 4.5 gigawatt hours for other energies from fossil sources. So that's for fuel, heating, etc. And other energies renewable, that's 0.3 gigawatt hours, not much. That's mainly wood for heating service. Some specific figures. There's a need for each cubic meter of delivered water. We have to put 0.17 kilowatt hours of energy. But that includes pumping, also fuel for mobility and so on. So everything is included in this value. And we produce or emit a value of 31 grams carbon dioxide per 1,000 liters of water. You see a pumping station, one of the 26 in Vienna. So now we look at the other side, the production. There are the 16 hydroelectric power plants, which are driven by drinking water. So this happens in the catchment areas along the transport lines, and also 3 within the city. The oldest one is from 1912, and they have a range from 50 kilowatts, so very small, up to the largest that one is 5 megawatts. So the annual production is 33 gigawatt hours per year. So that's 2.5 times the consumption we have. So here you see some photos of how they look. So there's a small one with only 100 kilowatts, 600 kilowatt, and the 5 megawatt. Actually, we have 2 possibilities. If we have the necessity to reduce pressure, we can reduce it by valves, so Clayton valves or globe valves, to reduce the energy, to convert it into heat actually, or we use it for energy production. So we have the opportunity to use Francis turbines or Pelton turbines, or the most cheapest way is just to use a pump, just to let it run the other way around. So this is very cheap. So if you have always the same height and the same discharge, it's almost the same efficiency, because the Francis turbine, it's used for different heights of level, or Kaplan you would need if you also vary in the discharge. But if the conditions are rather stable, also a pump is doing very well. This is called pump as turbine, the term. So here you see two pumps, together 65 kilowatts in a new rehabilitated reservoir. Here you see a map where the power plants are located. So that's all drinking water power plants. With respect to wind power, there's a problem in Austria that we have still provinces that really don't like wind power. So we made an overlay of all our plots, and there is no single plot or terrain in our property where we could make wind power. So this is still work for the provinces to allow the erection of wind power. So this is up to now not possible, but another possibility is solar power. A small one of only 6 kilowatt we operate by ourselves. And here is the first large one with 2 megawatts constructed on a large reservoir. So here we generate 2 gigawatt hours per year, and only with this one plant, that's 10% of our total electricity demand, or about 8% of total energy demand. This was the first plant made in the so-called PV offensive of the city of Vienna. I will show you this, what's the plan here. That's a strategy of the city. So the plan is to start from now 50 megawatt, what is now installed in the city, to come to 250 megawatt peak in the next 4 years, and to 800 megawatt peak until 2030. Only at the plots that are in the ownership of the municipality, the city wants to build 50 megawatts in the next 4 years. So that's a strategy of the city. And as we, as Waterworks, we are part of the municipal administration. We, of course, also in the boat. And as a first step, we have offered an area of 150,000 square meters that's in our property to dedicate for photovoltaic plants. So this corresponds to a possible power of 15 megawatt peak, but that's only within the limits of Vienna. And we have many plots also outside of the city. So at least that's the same amount of power possibility there. So actually it is planned to reach this in the next 4 years. And in order to take advantage of synergies, we do that not ourselves, but the municipal electricity company is building, maintaining, and operating this plant. So we only give the space, and they are doing the operating of the power plants. Well, you see here the graph of how the development should be. So it's a really dedication of the city, because until 2040, Vienna wants to be carbon free. Just a short step to financing. So the financing is done also by the electricity company, but there are offered so-called citizens power plants. So private people can buy a fictive share of solar panels of 300 watt peak, each at price of 250 euro. And during 5 years, they are getting their money back, depending on the production of this solar power plant. So there's guaranteed production of 300 kilowatt hours per year. And with the estimated production of 315 kilowatt, this amounts to a yearly payment of 53 euros. That means an internal rate of return of 2.51% for the people. This is running also some years, so that was also possible for wind power projects. And up to now, about 11,000 people have invested an amount of 39 million euro in this form of green electricity. We are also working on the mobility sector. So we have a fleet of about 150 cars. And since for 2 years, we have a procedure. So every time a car needs to be replaced, we are looking whether on the market there is a car available which covers the necessities that we have, because of trucks and tractors are not really available. So up to now we have 7 cars with electric energy, and we are still on this to reduce the fossil fuels. Another aspect is to reduce the electricity needed for air conditioning. On our headquarters, we have installed a green facade, and we have an evaluation made by 2 universities. And the result is that we can reduce the summer temperatures within the building of about 3 degrees Celsius. So this is it's better for the people working there, of course, and also for the cost of energy we need. So this was on the headquarter, and there's another that's new. That's an image photo that's on the control center of a reservoir where this was made in the year 2020. Well, that's my presentation. So for question, I'm free in the panel. Thank you for attention.
Thank you very much, Wolfgang. And now we'll switch it up again, and I'd like to invite Mr. Gilbert Schreiber, who will be presenting on energy management for the water and wastewater industry from Siemens. Thank you.
Welcome, everyone. Actually, great. A pleasure for us as Siemens to be partner of this event. We have a long-lasting relationship with Vienna Water, with a very advanced project or very advanced projects in automation, in energy efficiency, in data management, and actually to it's not working. Oh, there we go. To expand this to a region which inside Europe, Eastern Europe, we are responsible for as a group is actually a target of ours. If you can look at the map, it's almost equivalent, identical to the Danube Forum region. And we are fully active, not so much in Albania, Kosovo. So maybe this event brings a push to that one. And if you ask what can Siemens do in water for you, I'm still asked sometimes if we can repair the washing machine or the dishwasher. That's not Siemens anymore, that's Bosch Siemens. So the Central Siemens AG is now really focusing on infrastructure and on industries. And within automation, this whole portfolio of automation, of instruments, power supplies as well, up to cloud applications, is our target to make this available for solutions in water as well as in other areas like pharma, like food and beverage. Yes, to be really close to the branch is a thing which very much conducts our business at the moment and for the next oncoming years. This would give you a picture of how a company like Siemens would look at a project which could be energy management or which could be automation. So I'm responsible for something which is called vertical water and environment. And this means exactly to vertically integrate solutions from field level, like measuring, like drives, like communication, up to management level. So SCADA system monitoring, automating to a large extent and making things transparent and visible and working. Now there is a strong crisis, it has been said many times, is pushing things. Now there is a strong move from our customers towards a level management and engineering in the way of digitalization, in the way of connecting all parts of the system, in the way of predicting, and in the way of optimizing. So actually, I hope we are up to meeting your requests. We at least want to push and apply, and I hope I can show you some examples. Firstly, this is what has been said in the German guideline DVA 216 in the year of 2016, so already some years ago. You can see 25% of plants in average have a specific consumption of some 30 kilowatt hours per people equivalent in the year. 75% of plants have a consumption of 50 kilowatt hours per specifically. So simply looking at this relation, there is a average savings potential of 40%. No matter if this is really right for your region, for your country or not, if you calculate the total of this savings potential, and this has been said in previous sections many times, there's a huge amount of saving possible, and still there is, of course, a way how to do it, and I'm wondering if you are surprised. This is not a technical question to start things like that, but this is actually really a process and interaction and also social related questions. So what we see at projects is actually that success factors are concerning transparency at the very most important. So if you really have transparent, where are your energy, let's say, users or consumers, how is the complete process? So also balancing, looking at complete processes as well as the single utility, you need to look at the whole process. This is not a matter of software, a matter of software, of money, something. This is just a matter of approach. Identify weak points. So is there maybe a low maintenance on your blowers in the wastewater treatment plant? Do your pumps run not at optimal set point? Do we have a deviation from the baseline of comparing utilities or features? So if you contextualize, if you really compare your system after being transparent to other systems in the place, it's actually a very clear path on how to proceed. Again, this is not technology. This is actually a way of analysis and a way of doing things right. Peak load, of course, being part of the game. So if great consumers like us in water, if they can reduce peak or be producing or using energy when others are not, then of course we are a great part of also stability in the system. And of course, ever more coming up the question of procurement, of buying energy at reduced tariffs, whenever this is possible. A matter of transparency is actually to make things simple. So to reduce complexity, we have this had this many times, and therefore so-called energy PIs or KPIs can help a lot. So process indicators. This is the one for example, for a treatment, pre-treatment, mechanical treatment process station, where you can see, okay, one question, where to implement energy meters, where to look at the specific consumption, and then make this or relate this to inhabitants or the plant, let's say, layout. And then you have a simple factor which you can follow up, which you can put into diagrams, and which you can follow in historic and also predict later on. This would be, for example, a process with a software tool of ours, Energy Manager Pro, where you can very quickly and also intuitively display this data. So to create visibility, to show things also to the operating people. So this is actually a matter of really also connecting with people and understanding what they can do for the whole process. And finally, such a software will be exactly of best use there, where you can communicate right, where you can measure right in the first way, and then make this available to people. To show or to analyze, monitor such energy consumptions, there are several simple calculation methods like regression. So make an attempt to make yourself aware of what is the optimum of what could be expected, and then compare to status, and you will be aware of where the problems are. Finally, I want to show some examples which are maybe again a little different to what I've said just now. So our colleagues have, for example, in the last years, conducted a project at the Vienna water treatment plant, which is apparently the third biggest in Europe, 4 million people equivalent, where sludge was before this project incinerated at the company next door. And there was, with this project, a sludge digestion coming into place. Of course, under full operation. It's the only wastewater treatment plant of Vienna. So a task for us was to do this under full, the change of system under full operation, the change of the automation and the SCADA system. So there was also simulation in place. We did prepare software, we did prepare measurement, we did prepare automation, simulated, and then in certain packages transferred to real. Never needed to go back. So for automation, this can be a helpful task to conduct such processes. And like the example from Bulgaria, the Vienna water treatment plant is by now energy autark, even also more, 110%, not every month, but across the year, the energy balance is positive. Something from far away, but always look onto best practice. The Singapore Utilities Board actually operates 3 different municipal wastewater treatment plants and 1 industrial one. There is the target to reuse treated wastewater again for industry. And there is the approach to completely conduct a process of energy management for all of these plants. So they have been all of them connected, all the processes via the system Energy Manager Pro, and we see a major reduction of energy cost and energy consumption. And of course, I would also like to say and show that this is not only true for big cities. So yet, and I think this region, Southeastern Europe, is especially well prepared for making a big step towards trying out new technology. So we are requested. This has been even in the tender document, mind you, to prepare a dynamic process model for a wastewater treatment plant in Eastern Croatia, Southern Slavonia, for online simulating the wastewater treatment process, and not only that, to create a operator support model from this. So this will needs to be directly connected to the operators and giving them advice. Okay, start your blowers now, reduce your pumping now. The process is in good shape. The process is in bad shape. There is also a tool in place. So Siemens turns into a data company every more step by step to really install quickly such models, also to help engineering and to finally get this right through to operating people. Yes, finally, our conclusions. If you look at energy management projects, take care about measuring the right values, the values right and continuous. So it's a matter of really having things transparent and of continuously evaluating the history of data, add intelligence, add knowledge to data, make it simple. There is no need to be very complicated. There is a lot of need to be simple and to be transparent, to be understood by people. Create easy transparency. So pictures or software is actually best in place where we can picture, where we can visualize dependencies, where we can visualize histories of data. Connect to people. Never forget that this is the most important factor. These technologies can also only serve people, not the other way around. Finally, a very simple process would be interesting to get in place, which means measure, monitor, control, and finally manage. And this is a point which Mr. Kling and myself we just said before this session. So if today can be a starting point for you to really step into projects and to do things like that, every small step counts. Then I think we are really in this region have a really good opportunity to be ahead. Thanks.
Thank you very much, Gilbert. So I'd like to invite our panel to the stage. So we have you, Gilbert, and Wolfgang in person, and then we also have a couple people online. But just a couple words on my side. These were really excellent presentations on the technology, how to reduce demand, diversify supply of energy, but also to create energy in a way too. But what I found interesting was also going beyond technology. The messages were repeated a couple of times across the presentations about cooperating and working with others, if that's other sectors, citizen engagement, and the importance of that, and also contextualizing by comparing to other industries and other utilities, what's going on there, and really looking at these best practices, which is exactly our aim here today, is to look at some of the best practices in the Danube region. So thank you very much. And I'll invite Stipe back to the stage as well.
Thank you,
And
Katja.
I'll take a seat. Thanks.
Thank you. One more time, thanks to all the presenters. We are having a panel that includes presenter, but we also have introduced a few colleagues who are joining us remotely and who didn't make presentation themselves. So we'd like to invite them to maybe briefly present themselves, and I will immediately pose them a question. So Florian Kretschmer basically is, as far as I know, Florian, correct me if I'm wrong, lead researcher of the BOKU on Interreg project that was looking at the energy efficiency and renewable energy production on a public infrastructure with focus on wastewater. And I think it's also solid waste. Wastewater is what we are interested. Now, BOKU is, I think, one of the leading research institutions in Austria that's dealing with the sector of a practical aspect of the sector of water supply and sanitation. So maybe if you can briefly present the project itself and basically just inform us about a few key findings or key conclusions.
Yes, Stipe. Hello to everyone. It's nice to be back to Tirana, at least online. Stipe, you were totally right. So I was involved in an Interreg project, it was called REEF2W, and it was dealing about renewable energy generation and energy efficiency at wastewater treatment plants and energy generation out of wastewater and solid waste. This is just one aspect actually we are dealing on in, let's say, at our university here. We have a strong focus on energy generation from wastewater we have been working on that field for more than a decade now, because what we see is that not only these days, but energy supply and renewable energy supply becomes more and more important. And this is quite obvious, of course, but we have to keep one thing in mind. So I was also thinking of that when I was listening to the presentations. When we talk about energy, we recently used it as a synonymous for electricity, but basically energy is not only electric energy, we also have thermal energy. And we have to, let's say, if we want to succeed in our energy transition, it's not only necessary to look on the electricity, but it's also important to look on thermal energy, because European Commission stated that the heating and cooling sector is already the biggest sector in the European Union, and it will remain the biggest sector in the European Union. And when thinking of heating and cooling, this is where wastewater comes into play. We heard that wastewater treatment plants can become electrically self-sufficient, but this is anyway very challenging. But every wastewater treatment plant has surplus in thermal energy out of combustion of biogas or out of wastewater heat recovery. And until now, this was not a big deal because natural gas was quite cheap, but things are changed, as you said, or things are changing. And this is where our research recently focused on, thinking of the excess thermal heat we have at treatment plants, how we can use it, not only at the wastewater treatment plant, but in, let's say, local energy supply or heat supply systems. So this brings us beyond the fences or the premises of the treatment plant. And this was also what our Interreg project was about. How can we integrate wastewater treatment plants into local thermal energy supply?
Thank you very much. Maybe, I mean, since you are basically still based in Austria and know the country best, I mean, we saw the example of Vienna water utility. How much this isolated case, or how much this approach, when basically they were thinking about energy production way before the crisis actually came. How much is this widespread or already applied in Austria, or how much is this actually exemption from the general rule?
In regard to anaerobic digestion,
energy production in us.
Well, what was mentioned is that in this EOS project, the Vienna wastewater treatment plant installed, I think, 6 anaerobic digesters to be able to generate biogas out of the sludge. And this does not only happen in Vienna, but this also happens in about 163 wastewater treatment plants across the country already. But what might also be, so this is common, or has been common practice for decades.
It's actually industrial standard for a wastewater treatment plant in Austria.
It is. And I would say not only in Austria, but in most of Western European countries. What might be interesting when thinking of the wastewater treatment plant in Vienna is that they now also install a wastewater heat recovery facility in the effluent to recover the thermal energy of wastewater. And this will be, I think, the biggest installation in Europe, covering more than 100,000 households to supply with thermal energy from wastewater. And this, I think, is the, let's say, more interesting and the more novel approach compared to anaerobic digestion of biogas. So we have really to be aware, we have different sources of energy. We have the biogas, which can be used for electricity generation and heat generation. We have the effluent, where we also have the opportunity to recover heat, and we have the possibility to apply solar thermal or solar or PV. We have the possibility to apply wind power. We have the possibility to apply hydropower.
My last question to you is, what level of electricity prices need to be reached for this technology to be price competitive?
Well,
sorry if it's a tough
to
question.
say for the prices, especially as prices change on daily basis at the moment. Well, what we see from experience is basically wastewater treatment plants need a lot of electrical energy anyway. So, and it was mentioned that Vienna, for instance, can be energy positive or electrical energy positive, at least on an annual average. So I would say, and what we see from our experiences from the treatment plants in Austria, usually to have surplus electricity is not so common. Therefore, the question, what would be the perfect tariff to produce electricity out of biogas is maybe not the question. The question is, we should be very electricity efficient. We should generate electricity out of what we have. And we should also generate the heat and use the heat. And what we see is, even we started years ago with this integration of wastewater heat, either from biogas or from wastewater heat recovery into local energy supply concepts, into local district heating. And even 1 year ago, 2 years ago, when natural gas was still very cheap, it was competitive.
Okay.
And therefore, I think it's not the question about what price would be interesting. The question is, we have the energy below our feet, we must use it, and this would also increase the resilience of our systems. And I think this is the major question we face now. Of course, money is one aspect, but supply security, I think, is even more important at the moment.
Thank you very much. Very good answer.
Your mic is off, Stipe.
Let us move a little bit outside Europe. We are fortunate to have with us my colleague from the World Bank. Camilo is based in Washington, D.C., and we are glad to have him with us. Camilo, maybe if you can just briefly introduce yourself, and if you can basically bring us any kind of experience related to energy efficiency and production of energy from water and wastewater facility from outside of Europe, World Bank or otherwise, that you have experience firsthand.
Yeah, thank you, Steven. So, Steve, so first, my name is Camilo Lombana. I'm a senior water supply and sanitation specialist. As you mentioned, I'm based in Washington, D.C. At this point, working for the Europe and Central Asia region, right? Basically in Albania and Kosovo, supporting other countries in the region. So I think, when we talk about the innovation and technologies, I think that there are several good practices that we're seeing around the world. Definitely what was mentioned here is somehow the trend that we're seeing in other places. But I think that I would also like to highlight that innovation probably could go beyond technology, Steve. So it's not only about having these mega investments to bring on new sources of energy, but it's also about how on a daily basis utilities and utility staff can be innovative to be more energy efficient, right? So the point is not how you bring on more energy, and if you are still not being using the energy that you have efficiently, but at the end it's just to see how you close down that balance, right? So what we are saying here is that there are small actions, small interventions, small initiatives that are being led and somehow championed by utilities that somehow are also making the change. So there are several examples that basically are being gathered through the Utility of the Future initiative that has been implemented in 60 plus utilities at this point around the world. So let me just mention a couple, Stipe. So for example, we're seeing like the use of smart meters as a as a very innovative way of trying to understand and trying to gather that and trying to see what is the best way or where the energy is going, right? Probably the gentleman from Siemens in his last slide was showing that one initial point or a key point here is just trying to measure. So smart meters and analysis of big data seems to be something that is not expensive to do, seems to be something that is very impactful and can definitely point out what is the direction on how the utility could improve the use of energy. Also, in these terms of energy monitoring and energy reporting, what we've seen is that water utilities, of course, are experts on water, yet they are not experts on energy. But what we have seen is that there are many utilities that are having close coordination with energy providers, and by doing that, they try to adjust the energy purchase strategy. They try to get guidance on how to better measure the energy consumption. So this kind of again, innovation is not only technology. This kind of innovative approaches are definitely helping utilities on that regard. Also, there is something that is very important as well for the water utilities is the demand side management of the chain, right? So what we are seeing is also that there are different ways of the use of multi-channels to interact with users and drive the consumption optimization. So ideally, is just to see how utilities can engage with their user. There are like different ways of doing that, just to see how the consumption can be optimized. Again, simple activities, but yet we are seeing that this is somehow driving down the consumption of energy. Then also, as part of that, we are seeing that there are several utilities that, as part of this constant improvement that they have in their organization, they are making arrangements, or they are partnering with the startups. They are partnering with solution providers to test and implement different technologies within the utility. So this is also something that, again, does not require a lot of capital expenditure from the utility. It does not require a lot of effort, but just does give that room for all these startups, for all these R&D groups that are out there to test, to see whether those innovative technologies or those innovative approaches can be used in that particular utility. So just to wrap up then, Stephen, with your first question. So I mean, we are seeing different technologies, and I think that the examples that were presented were excellent, and they do show the kind of achievements that can be made by introducing those technologies. But also to highlight that you don't need to change your entire utility. You don't need to have a very sophisticated onboarding bioreactor for you to have your utility be more energy efficient, but it's also something about the daily management of the utility, something about the drive to improve the performance of that utility, the drive to improve the energy efficiency that each of those utilities can implement and can start doing that tomorrow. So let me stop here for your
Thank you, Camille. No, I fully get your message, basically being that, it's not only just investing in new equipment, but it's also about managing the processes and the operations that we have even present level. Since this session is still on technology as such, and we have a representative of Siemens with us. Now, if I can ask just maybe one question, I mean, out of professional curiosity, in which direction do you see that main technology drive will still go, at least from the standpoint of Siemens? Will this be on basically artificial intelligence management of the system? You basically also focus very much on the system, but is there any kind of new emerging technology that we can expect that will result in significant additional energy savings or energy production in water supply and sanitation systems?
There is one point I can mention here, which comes more and more into practical life of operation of water systems, which I would sum up under the idea of a digital twin. So while beforehand, everybody in water, and I'm myself civil engineer, so everybody was looking on the process and looking on the thing itself, and the truth is only there. We see now that colleagues of us, operators not only of big treatment plants, they really think of using simulation and optimization on the basis of a model. Simple and complicated, no matter, and to really by the use of such helpful devices to set processes next to it, and they can be purely, of course, technical, but actually there is more and more use of software and application of modeling.
Okay, thank you on this clarification. Katja, maybe now it's a good point to hand over and ask our audience, do they have any question? You can probably handle that better than I can remotely at this point.
Yes, happy to do so. So we do have 15 minutes that we've scheduled for Q&A from the participants themselves. So if you have a question, I think we have a floating mic. If you could raise your hand and then we could bring you a mic. Don't be shy if anyone is interested to ask our panelists here.
Thank you, Katja. Quick question, primarily to Gilbert, but probably also to Florian and whoever wants to take the floor. Probably Julius as well. Compared to other energy-intensive sector, how ready and how suitable is the water sector to provide demand response buffers and capabilities and options for energy traders, balancing groups, energy service companies, and others who can help water utilities reap that potential? Wolfgang, probably also to you as from your experience. Thank you.
Maybe I would like to hand over this question to a colleague of mine who is also in the line, Steffen Händler. Steffen, do you want to respond to that one?
Yes, I can do. Hello from my side. I'm here in Nuremberg and a colleague of Gilbert. Regarding the question demand response for water industry, I can see a big potential here because, for example, especially if you have installed digesters with storage of your gas, if you increase, for example, your power generation capacities, it shouldn't be a problem to participate in the demand response market in this case. The other thing is, for example, using buffer capacities. So if you have, let's say, a 2-point controlled pump, perhaps it's possible for you to avoid the switching on simultaneously of multiple pumps at the same time. And this could also be a possibility how to avoid peak loads inside of your plant. My opinion, a really big potential is in your own generation. So if you're able to increase your electricity production higher than your own demand, it will be a really good possibility for you to join in the market and for sure also to make money out of it. Question answered?
Thanks, Stefan. And Gilbert, did you want to also reflect?
Well, in the case of Vienna, there is a potential, but I would not estimate it too high because the pumping times are mainly driven by water demand. So we also always try to maintain the storage on the level that we need for the water demand. And so there's little adjustability for looking at pumping times. And furthermore, we don't have different tariffs, whether we pump during the day, during the night. But what we, of course, have is to pay the peak load. That's true.
Maybe I can also add some words because I heard my name. was mentioned. I basically also agree that there's great potential. But as already mentioned before, if we want to somehow integrate different ways of thinking, let's say wastewater treatment, water pollution control, water supply security, energy supply security, we have to bring the different stakeholders on the table. So this is just an integrated approach. We need a lot of appropriate data. So it's about the measurement and the monitoring. And ideally, we have, let's say, one common platform where we can somehow manage all these approaches. And this is, I fully agree what Gilbert said with the potential of digital twins. So those can be very helpful in these aspects. Also, the approach of building information modeling can be an option here. And I think must be an option if we think we want to have smart cities in future. So if we want to become smart, we have to think of what type of data do we need, in what frequencies, in what quality, who of the stakeholders must be involved, and then what are the different approaches we follow in our, let's say, local, regional context. So it's not only about wastewater treatment anymore, it's not only about water supply anymore, it's not only about waste management or energy supply. It must be an integrated view on local level, on municipal level, in my point of view.
Thank you, Florian. I think we have another question in the audience.
Thank you. Hello to all. I am Alberina Goshi. I am from Young Water Professionals from Kosovo. I want to make a question for Mr. Gilbert from the renewable energy. That's very important and interesting point. Do you know what is the percentage of the energy that's created from the wastewater treatment compared to the energy that plant is used, and also compared to the energy that all the Vienna city consume? Thank you.
Sorry, the whole energy consumption of Vienna I have to pass now. I don't have the data. What we know is that the treatment itself, we are the same like the plant in Sofia. We are about 110% of energy supply for the treatment. And this mentioned use of heat of the wastewater. This plant has a power of 110 megawatt, what is now installed, 110 megawatt output and 36 megawatt input of electricity. So this is used for district heating. But the comparison to whole Vienna, I can't say now, because there's also industry and this value I have not present.
Thank you. And another question, thanks.
Hello, Erion Kalaya from Albania. Just wanted to ask Vienna Water, taking also from Florent explanation now that the systems are more integrated, and Vienna Water explained that they do not manage all of their electricity production. So how do they integrate their core business, water supply and water treatment, with energy production management and that part? Thank you.
Within our company, we have a department that's responsible for the electricity issues. So because we have pumping stations and so on, and with this personnel, we also manage our own water, the hydroelectric plants. And just these two hydroelectric plants are managed by the electricity municipal electricity company. And also all of the future photovoltaic plants will be managed by the electricity company. So this is actually the separation of core business. So they put it on our reservoirs. We can use the electricity, and all what is not used by the waterworks is going into the network and is marketing is also done by the electricity company. So they sell it on the market.
Thank you. And just a brief reminder that we also have Yelas Rangelov still on the line from Sofia Water. So if you have any questions for him, please feel free to raise them. Yes.
Hello, my name is Ljubomir Filipov from Sofia Water Company. Actually, my question is not to Željas, whom I'm meeting almost every day, but my question is maybe more for the World Bank representatives and maybe Siemens. Actually, in my view, the water sector is one of the most conservative sectors in terms of penetration of innovations. So my question is, what do you think that the water sector and the water utility companies should do in order to shift from, let's say, moderate and emerging innovators towards, let's say, leading innovators? What do I have to do in that direction? Thank you.
Thanks. Gilbert, did you want to respond, or Stipe, Camilo? Floor is open.
I can come in.
Okay.
Yeah, so I mean, I think it's a great question. I somehow agree with the statement, right? So we have also seen that there is, and probably there might be some correlation with this, is that the water utility sector fails to attract a young talent, right? If you compare water utilities with, for example, power utilities, the young people or young professionals tend to go much more to those power utilities, right? And even when you compare within the public sector, like for example, water services or transport services, young professionals also tend to go to more to those other sectors like transport, for example. So the thing is that when we fail to attract young talent to the sector, then somehow we're also being less competitive, or we're also being less efficient on trying to improve these newer technologies and newer approaches, right? So I think that there might be some correlation about that. So then I think that what needs to be done is somehow to integrate this constant innovation in the DNA of water utilities, just trying to find different ways and different avenues for utilities to allow staff to be innovative. So probably a couple of examples I gave before regarding how utilities should also allow, for example, startups or R&D companies to work with the utility, to test with the utility these new ideas. So probably when we start like thinking about that, when we start seeing what would be the benefits of including new technologies and once again new innovative approaches into the daily operations of utilities, I think that's when we're going to be able to somehow start being more competitive in terms of the use of new technologies and new approaches. Let me stop here, Katya. Thank you.
Katya, if you just allow me quickly to add, I actually think this is an excellent question, and I like the expression of the water supply and sanitation sector being conservative one. Quick answer, if I think on top of my head, would be basically because the sector is mostly monopoly. It's actually in most cases natural monopoly, and as such is not necessarily under pressure of the market to transform and adopt. As I said in my initial statement, it's basically necessity, and this huge hike in energy prices that is basically forcing us to discuss this. Otherwise, we'll probably not even. This would not certainly be the focus of our priority. So the sector, by its definition, is a sort of national priority, very often run by local or the central government. And as such, this lack of market pressure, with few exceptions, lack of market pressure is not necessarily best driver for change.
Maybe I can add one thing. I think the ecosystem of the country, or even the broader region, is actually a very important driver for technology. Mind you, there is funding and public money involved. That there are programs in place. There are associations working with this money, with these programs. There are technology companies who should be more involved, like ours, in order to also push technology in programs. And if there is, it's hard to say, but if there is a need or if there is a force to be innovative, then also the conservative branch will need to follow. So I think there also needs to be a top-down innovation pressure to be applied for being more innovative in the branch.
Thank you, Stefan.
Yeah, perhaps from my side, I got also impression in the past that energy efficiency wasn't the top priority, but okay, that's natural. your priority is to supply water or water treatment. So this is the main target in the past. But on the other side, it can also be a kind of opportunity. So if you're at the beginning, there is still a lot of saving potential for you to achieve, to save money, to save energy, to get a green image for your plants.
Thank you. I think we have time for one more burning question, if anybody has one. Walter?
Well, thank you. And I just want to reply on Stipe's comment about the conservativity of the water sector. Yes, I recognize that we are a natural monopoly, but even in this development now, we also need to mention the flip side of the coin. And it's always for the municipalities and the political leaders easier to control a monopoly and to be in control of the development. So what we need to discuss as well, when the energy market was a monopoly years ago, before the market was open, the political control was really also having a substantial impact on the sector. We are facing the same not currently, but ongoing in the water sector. And I think this need to be discussed as I say, the flip side of the coin. If political leadership is done properly, and I would take Vienna as an example, where there is a very supportive role of the politics in financing activities, in allowing innovation, then this showcases good and innovative developments. If politics is a little bit touring down the activities, and we heard this in the session before, that leaders of utilities are quickly changed under political pressure, then I think we also need to advocate for clear recognition of the politics, whether this is good leadership from their side. And I think EAVD and together with the World Bank, we are playing a role in raising this awareness in the leadership of municipalities.
Thank you, Walter. I think this is basically very nice bottom line for this session today. At the end, we are all jointly together. But I'm pretty certain, as I said in my opening statement, this topic will be the focus of all our activities in some foreseeable future. So we'll see each other again, and we'll continue this discussion. I'm certain in the years to come, and I'm sure that political leaders, as well as the European Union, who is dominant in our region, will put additional financial resources in this particular sector. So, Katja, finally, I'm signing off, and over to you.
Thank you, Stipe, and thank you to the presenters and panelists for an excellent session. And now we will be heading to lunch, so I don't want to delay any further. So thank you, everybody.